In this video, we will be covering some of the properties of limits. There are 9 total properties that you're going to need to memorize, and in this video, we are going to cover the first 4. The first property is really straightforward. The limit as x approaches a of some constant is just that constant, regardless of what a is. Just to give you a quick example, so say we have an f of x equals 5, also known as y equals 5, right? Very basic straight horizontal line. The limit as x approaches 3 of 5 equals 5. And just to hammer this home one more time, the limit as x approaches 8 of 5 also equals 5. The second property is almost as easy. The second property says that the limit of x as x approaches a is just a. So a quick example, say we have a function f of x equals x, or also known as y equals x, and we want the limit as x approaches 4 of x. Well, according to this property, that equals 4. The third property is also really straightforward. It states that the limit as x approaches a of x raised to the nth power is just a to the nth power. So you're just plugging in a here. A couple of quick examples. So say we have a function f of x equals x squared. Say we want the limit as x approaches 5 of x squared. So we're just going to plug in 5, and that gives us 5 squared, which is 25. Let's do one more example. Say f of x equals x to the 5th, and we want the limit of x to the 5th as x approaches 2. So again, according to this property, we just plug 2 in, and we get 2 to the 5th, and that is 32. So the limit as x approaches 2 of x to the 5th is 32. The fourth property, I'll be honest, it's a little trickier than the first 3, but bear with me and I promise it's really not too bad, especially once you get used to it. It states that the limit as x approaches a of f of g of x equals f of the limit as x approaches a of g of x. Now I know that all sounds really confusing, but just bear with me, right? So what we have here are nested functions, and don't let the f and the g of x confuse you. They're just two functions. F of x is a function, g of x is another function. The letters themselves don't mean anything. You could also see an h of x, right? It doesn't matter. They're just two functions. But let me explain to you really quickly what nested functions look like. Let's look at an example. Let's say we want to take the limit as x approaches 3 of e raised to the x squared, right? So e to the x squared. Let's look at this. So x squared is itself a function. We looked at that earlier in the video. And e to the something is also a function, right? We've seen e to the x, e to the 2x, e to the something is a function as well. When we look at it, e is raised to the x squared. So that means that x squared is our inner function, and e to the something is our outer function. So that means that x squared would be our g of x, and e to the something would be our f of x. So we're plugging in g of x into f of x, right? The x squared is going into that e to the something, so that makes it e to the x squared. What this property tells us that we can do is when we see something like this, the limit of a nested function, we can just take the limit of the inner function, in this case, the x squared, and remember, that's going to give us a number, right? It might give us 2, it might give us 4. It's just going to give us a number, and then we can just plug that number into the outer function. So it's just going to be e to whatever that number is. And let me show you. Remember, e to the something is our f of x in this case, and x squared is our g of x in this case. So the property is telling us that our initial problem, the limit as x approaches 3 of e to the x squared, can be rewritten as e raised to the limit as x approaches 3 of x squared. And that smaller limit we know how to do, right? That was an earlier property. The limit as x approaches 3 of x squared, we can just plug in 3, right? We looked at this earlier. So that gives us 3 squared, which is 9. And now we can plug 9 back in to our initial formula. So the limit as x approaches 3 of e to the x squared equals e to the 9th. And I would leave it as that, but if we want to get a little more precise, it's about 8,103. So make sure you really understand this point. We had the outer function and the inner function. We took the limit of the inner function, and that gave us a number, right? In this case, 9. And then we plugged that 9 back into the outer function and got e to the 9th. I'm going to quickly walk you through one more example of nested functions. I'm not going to completely calculate the limit because it's a little more advanced than where we are right now, but I am going to show you how the limit property applies to something like this. So let's look at sine of 2x squared minus 3. 2x squared minus 3 is a function, right? We can imagine graphing y equals 2x squared minus 3. Sine is also a function, right? We can imagine graphing y equals sine of x. So we have a function of a function. 2x squared minus 3 is our inner function, in this case g of x, and sine is our outer function, in this case f of x. So the way this relates to the limit properties is that if we had the limit as x approaches a of sine of 2x squared minus 3, we can rewrite that as the sine of the limit as x approaches a of 2x squared minus 3. So remember that the limit of 2x squared minus 3 is just going to be a number. And then you're going to take the sine of that number, and that's going to give you your final answer. So you take the limit of the inner function, 2x squared minus 3, and then you plug that into your outer function, which is sine. If you found this video helpful, go ahead and like it and subscribe, and I will keep the math content coming.